And 30 seconds to focus. Oops. Those away. Fruit or vegetable. Put them away. You can have them during snack or during break. Again, like this is what the expectations are. If there's no, hopefully you're not surprised by any of this stuff. Does anybody know what character counts means? Like the program is called Character Counts. Why would it be called that?
That is important, like to advise.
Yeah, who you are and what you do is important. Like the decisions that you make are important. They affect everybody. It shows what you think is important. And that's what people look through. They go, this is what this person does. Right? This is what they value. So whatever you do, good or bad, that's what it shows. Here we can say things, right? A lot of people say your actions speak so loud I can't hear what you say. It's a very famous English expression. Right? Because a lot of times we say stuff, but we can't live up to it. So, difficult stuff, being a good character. Man.
Yeah, no, it was, and I forgot to change it once again. Bummer. You did. So this is the mini thing from 14.
Okay. Let's see. Milagros, what part of the eye lets the light enter? The pupil. Awesome. What's that? What is the job of the lens? Martina, the pupil lets light in. The lens is the lens tube. So think about this. Think about the magnifying glass yesterday. I got close and made things, or it came to focus. Very close. Call on somebody to help you.
It focuses light to the thing.
Focuses light on the red. Awesome. Violetta, what is the role of the red? You can always ask that. Yeah. Into the electrical signals. Awesome. And then, let's see, Augustine P. Where do the signals go after the red? The optic nerve, and then through the brain. Wampa, if an image is blurry, even when there is enough light, what might be happening inside the eye? A lens problem. Cool. Yeah, it could be focusing the light before or after the retina. And then Martine R. How does conduction stop?
When it is like equilibrium.
There it is, equilibrium. When things are equal, when the temperature's equal. Cool. We're going to be talking more about the brain today. We're also going to be preparing ourselves for that formative that's coming up next session. It will be tomorrow. Like I told people, that formative can improve your grade if you do well on it. If you don't, it won't damage it. Right?
It will damage.
If you do not do well, it will not damage.
But if you do well, it does.
It can improve it. Yeah, it can
Like the
improve it.
optional extension.
What's that?
Like the optional extensions.
Correct, yeah. And there'll be optional extensions on this assessment. But yes, it can't hurt you, but it can help. And it's going to prepare you for the final stuff.
Tomorrow we have the meeting.
horrifying.
Yes.
Did I? Amazing.
So success, we really want to be thinking about how many arrows we're using in our models. Okay, we're wanting to make sure that we're writing those process verbs by them. We really need to make sure that we can explain why things are happening. That's an important piece of
What's that?
explanation. What's that?
What's that symbol?
This one?
Yes.
Greater than or equal to. So we want at least 5 arrows when we're doing models. We want at least 4 verbs describing them. Words today: perceive, interpret, information, scatter, claim/evidence. So getting down ideas and thoughts about those, as well as answering the question: why is the brain important for seeing? If 2 people look at the same setup but describe it differently, what is one scientific reason that can happen? In the box scenario, which is this, what changes when a translucent material covers the window? What is the full system change for seeing in order? And what is one sign your model is high quality? Go ahead and do that work. And then we will start. Can you go to nurse one? Can you go to nurse? Oh. Yeah. Okay. Trying to get down what you think those words mean. Answer the questions. What's that? The lens is here. Focuses the light onto the lens.
Scatter.
Scatter. So you should already know that one.
Different important social culture shows different identify the things. Different important social identify the things. Mr. Ryan.
What's up?
I don't know that.
You're not necessarily supposed to know anything. You're supposed to think. You're supposed to think and answer. You're wrong.
We don't know that question.
I mean, you probably should, but you've missed a ton of class, so I wouldn't expect you to know them, but that doesn't stop us from trying to answer. Because if you think about something and get it wrong, your brain gets better. But if you think about something and don't try, then it doesn't. It probably gets weaker. Don't treat your brains like they're cabbage. They're cordial. You only get one. Don't treat your brain like it's a piece of cabbage.
What's that?
Repojo? You don't know what repojo is?
I don't understand.
If we don't practice with our brain, like thinking, then we're treating it like it's not a brain. Your brain is in charge of like thinking and understanding and all that stuff. If you don't use it like that, then you know what's the point? On some level. The more you think, the better you think. The more you know, the more you learn. Just try stuff, Chris. Okay. So we need to think about the brain, and its role in seeing. We need to make sure we understand all the different pieces of how we see. We need to be able to communicate that to people because we're scientists and scientists need to communicate ideas. And this is where you will know if you have like a grasp of stuff. Okay? If you can think and remember information, you can use it. If you can't remember it, you can't use it. Okay? You always have to check ChatGPT or the internet for stuff. It makes it really hard to use information. Okay? This is the very famous examples, like if you need a surgery, right? And you have a doctor, and the doctor's like, let me check. And then they have to go to the computer and see what they're supposed to do every time. Like, you don't want that doctor. Right? So you should know stuff. You should know stuff. Knowing is good. Okay, so this is the full cycle now of being able to see. We have a light source. Okay, the light comes out of the light source. It interacts with an object or material. It again gets to our eye. Inside the eye, it gets to the retina. The retina converts it to a signal, and then that signal gets to our brain. If you change any, if you include the lens gray, right? This is the main thing that we need to understand. Okay? The lens would be where? In here, right? In between the eye and the retina. So we could talk about what the process is. So this is the very main process and where things change. If we change any of this stuff, okay, this is where meaning comes from. So your brain, okay, collects information from what you're looking at, listening to, all of that, and then makes meaning out of it, and then tells you what it's doing. Okay, that's why people can look at the same thing and have a different meaning. Okay, maybe the light's different, maybe their eyes are different, maybe their experiences are different, so they have different perception. Okay, they have different thoughts. Yes, Martina.
Like the signal after retina, it can be like optic nerve too.
Yes. Okay, but the main idea to understand is that the retina has to change into electricity so it can get to our brain. Okay. If we go back, and I forgot to mention this here, if we go back to these three words, again, we have information. That information gets interpreted by our brain. Again, it's locked in a box. There's no access to the outside world except what you're looking at, what you do. And then it decides on stuff, and it tells you what you see. People see strange things all the time that don't exist, but their brain thinks it's there. People who carry around cell phones in their pockets. Every once in a while, when the cell phone's not in their pocket, it feels like it is. And it vibrates, and you're like, oh, well, that's weird. Why? Because your brain doesn't know what's going on. It's like, I think maybe this is what happened, so let's make a little thing.
Yes.
Okay, that's what your brain is doing. Your brain's trying to figure out what's going on based on what information you're giving. And so again, so if people have any of this stuff is different, their perception and meaning can be different. So all of this stuff is required for our brain to create meaning for us to understand the world. Okay, so that's why you change any of this stuff, it can change the meaning of it. You could just wait till break, which is coming up, right? Good time to do whatever that is. Okay, so if we go back to the box, we have different things happening inside the box. When it's completely closed and the light's not on, you can't see anything. Right? You turn the light on, you look through the hole, oh, I can see paper. Okay? You turn the light on and you look through a translucent material, And you're like, I can kind of see the paper, but it looks blurry.
I have all this.
Okay, so all this stuff we need to be able to explain. Yes, Augustine.
Now, if we turn on both sides, what do you see?
If the light could be turned on both sides, what do you think you would see? If you had to guess, what do you think?
No, like in the video we saw, like.
Right, but what I'm saying is like if the light on was in both rooms, what do you think she would see?
And
You think she would still be able to see the other side?
you would not see anything from both sides.
You would just see the reflection.
Yes.
And what would say?
It's the same.
Say? What do you think?
You see the sides.
You think you'd see your reflection and what's going on the other side?
Like if you see one phone, you see the other side. When you check your phone, you see the other side.
Okay.
Because when you get it out and it was out, when you turn it, you may see one side, and when you turn it, you may see transparent.
I will ask the makerspace to make it to where we can turn both lights on so we can find her. Cool. Because it has to be one of those, right? Something has to happen. Cool. Alright. We need to be able to explain. Okay, so you need to be able to explain that. You need to say, this is exactly the reason why this happened. And our explanations have to get deeper and better as we go along. So when the light is off, nothing reaches my eyes, right? No light reaches my eyes. And because no light reaches my eyes, I can't see. When the light is on, light travels from blank to blank. We could go all the way, but we go back to this. We could say it goes from the light source to our brain. That would be accurate. You could say light source to material. You could say that too. You say light source to eye.
Can we say eye to brain?
The light is on, light travels from my eye to the brain. I mean, you could say that. I think I'm going to go source to brain. Some light reflects or transmits and then enters my eye, so I can see. So before it was like the light just needs to reach my eye and that's a fine answer. It's not a fine answer anymore because we know more. Okay, so we have to make sure our answers are better. At the bottom, with translucent material, light is transmitted, but what's wrong with the translucent material? We have, yeah?
It's
Scattered, right? It's spreading it out. So we're scattered, so scattered is spread out. So the object looks blurry. You could also say it looks dim. Okay, something's going on. It's taking less light is getting into your eye. Bless you. And so taking all of this into account, we have to be able to make a really, really good model. Can I do it this way? Awesome. So now all of our models need to have all of those parts to it. So we need the light source. That was a bulb. We need an object. We have my paper. We need an interaction. If I can't remember what those interactions are, that's going to be a problem. One thing I can do is like write them down. I know there's reflection. There's transmission. There's absorption. Oops. Anything else? Scattering. These are all good process words that I need to include. And I'm probably going to have letters. So I have the box. Oops. Here's the hole. I'm going to have my eye out here. I have my optic nerve. I have my brain. What are the pieces of the eye? I have the pupil. I have the lens. I have the retina. And now I need to start the path. Did I forget anything? So it leaves the bulb. It reflects off the paper. It transmits through the air. I can even have this coming in here, transmitting. Some of the energy has to be being absorbed by the paper because it would make a shadow. And everything absorbs and reflects at the same time. This is going into my eye. I could add the translucent material, and if I did, I would need to make sure that the light kind of is spreading out and scattering. So that would be something to keep in mind too. It's entering my eye. It gets focused on my retina. So here I'm going to put F equals focused, E equals enter. And then we have a change in the retina. And then it goes in that squiggle. So I'm going to say the squiggle is a signal. Bless you. And then my brain. What does my brain do? My brain processes or it interprets. My brain makes meaning. Okay? My brain makes meaning of what I'm seeing, what the information is that's coming into my brain. Okay? Pretty close. I might have to explain why it's being absorbed and reflecting and transmitting. Like remember the annotation? So if I put some sort of annotation because it's a solid or something like that, that would get me there. That would push my thinking a little bit more. So this is expectation for sure. Maybe even then it would be adding the translucent material. I mean they are delicious. It's just not the same. So here, if I had translucent material, I would need to label it. We're so close to break. I would wait. And so I have the light interacting with it. Some of it transmits, right? But it gets scattered. So how do I show that it's less than what it was before? I would put maybe an X. I would put maybe little dash lines. Okay, because now we see that has that scattering, spreading effect. And so now it's less than it was before. And then same thing, light getting into the eye. Cool, Dave? All right, at this point, take 30 seconds, write what you remember, draw something. Write down a question. You're going to give it a chance to practice. How many people want
The eye, then it's to the retina.
So yeah, the one I showed was eye and then retina. That's it.
Source, the object,
Signals, frequencies. Bless you. Bless you. It looks weird. Just remember, we always have arrows. Those arrows should be. You have the starting arrow. That's good. And then there's more arrows. And 3 questions before we go.
Wondering if you like the vibration
Uh-huh.
on your self-focus and how your brain captures the
I mean, it kind of your brain remembers scenarios and then responds that way. So something kind of made it think that was happening. People who lose limbs, like my stepmother, she had her whole leg removed because she had an infection in her hip. So she'll still feel her leg even though it's not there because the brain doesn't really understand that. Right? So the brain is just trying to interpret and process what's going on.
When Mr. Light, that you come up with like that the pupil is like a letter C.
Let's slide in.
Yeah,
Uh-huh.
but in that thing that you make like source object tag, where would it
The
go?
pupil would be right in the eye, like right before the eye. So the pupil is letting the light in. So it's the first part of the eye. Good question. Third question. Now we get the break. Food.
And that brain light if we know what we are seeing, but why does the brain like when we don't see anything like see stuff?
Because again, like the brain is trying to figure out what's going on, and so sometimes it's just mistaken. There's even been they'll show people like a police video of like a crime or something, or like maybe you have to figure out is it the person that caused the problem or the police officer, and they'll show it to a bunch of people, and depending on what people originally think anyway, that's what they see. So I'm sure you play sports. Referees make mistakes all the time, yes? A lot of times they think they see stuff that doesn't happen, because they have we call that bias. So when they think something's going to happen, and then they call the foul, because they think that it happened even if it didn't. Does that make sense? So it all is about anticipation. It's a really good question. All right, everybody, have a good 8 minutes. How does light interact?
Yeah,
What do you mean?
after the lens, does it go exactly?
It still goes to the retina, it's just less light. That's why it's blurry. Why is there transition? Why is there why is there?
Delegado, ¿será que puedo hacer algo con tu pregunta? Y en el celular, tigre. Y ya. Y ahora terminó. Y por eso ahora
It's weird what we see in our brain.
entonces, claro.
Like we don't see it in our eyes, even though it feels like we're seeing it in our eyes.
Mr. Light? My ear.
You need to go nurse.
I wanted to like
Eyes from the office.
what?
Mr. Light. Mr. Light.
I go directly now.
No, go first. Because sometimes they have too many people there. Okay, at this point, it's you practicing how you can explain things using scientific language, getting all the ideas that we have. Alright, so this first one, the scenario is just what I went over. A student places an object inside a box with a small viewing window. The inside of the box is dark. When a light is turned on inside the box, the object becomes visible through the window. When the light is turned off, the object disappears. Later, the student covers the viewing window with a translucent material. The light inside the box is still on. So in your session notes, fully and completely explain why the object is visible when the light is on, but not when it is off. Describe how the object will look when the translucent material covers the window, and explain why the appearance changes using light source, light interaction with materials, light entering the eye, etc. Okay, so practice that out. We'll share some responses, and I will tell you what grade that response will get. You can practice this. Okay. Go for it. It's about 5 minutes to work on from your desk. What do you know? You can cover notes. If you look at your notes as you're answering, that's not going to help you out. Then you have to check in with the person who's sitting next to you. Yes, ma'am. Is that? Can you write what? Just try to get through all of them. All three. Explain why the object is visible when the light is on, but not when it is off. What it's going to look like through the translucent material. And why do appearances change? So that object is either visible, not visible, or blurry. Why? can you explain things like a scientist? What access do you have to the words in your head?
Eyes are
Another 2 minutes. So, why do things change? So why does the object look different when the light is on, when the light is off, and through a translucent material? What's it? So you would agree with me that whatever object is in the box will look different depending on if the light is off, the light is on, or you're looking through translucent material. Yes? Why?
how many times is there?
To finish this?
Yeah.
30 seconds. Five, 4, 3, 2, 1, 0. Does anybody think they have a 3-level explanation for A?
I think.
So this is A. Explain why the object is visible when the light is on, but not when it is off. Go for it.
Okay, so the object is not visible when there is no light because like you can't see without like reaching your eye.
Okay.
And the object is visible with the light on because the light is reaching your eye and you are seeing the object. And the light is like like
What do you think is spreading?
spreading out and is como se dice, como reflecting on the object in reality.
Okay, really good. I wouldn't necessarily talk about scattering quite yet, but the idea of reflecting and transmitting, perfect. So he met expectations there. Okay? So if you want to meet expectations about talking about being able to see and not see, that's what you need to include. Okay, you include less than that, you're not meeting expectations. Does that make sense? Well, yeah.
Okay, read it.
Sure.
Because when light is on, it bounces everywhere, including the objects, meaning it travels to your eye if there's no obstruction to light. But if light is off or blocked, lights won't reach your eyes or not at least enough. Meaning all the process will break down and won't reach your eye, meaning you won't see.
Okay, super. My one suggestion there, instead of bounce, say reflect. So at this point, it's more scientific to use those terms. And we also remember that light is also transmitting through as well, so making sure those interactions are there. Awesome. All right, what about B? Does anybody feel like they have a really good B one? Martine, or
Like the object, I think it will look like blurry because like the lens cannot focus on the object because the light is all scattered.
It's all scattered, yeah. And because it's scattered, does that mean the same amount of light, more light, or less light is getting into our eye?
It's getting the same, but because it's like all spread out, it doesn't like get all the same light.
Yeah, we would call it actually less organized. So because it's being scattered, you could say less light is getting or less organized light. And that would be a great answer. Yes, sir.
And the object will look blurry because the translucent material scatters light, so there's less light and there's not enough to see.
Okay, yeah, less light is entering, it's less organized. Perfect. So we need all of that stuff. And what about C? C, let's hear something new. Yeah, please go for it.
See,
Why do appearances change? This is a very fundamental question.
the light source may be different, like on, off, dimmer or brighter.
Mhm.
It may be by the point you're looking or the object it is bouncing.
Okay, super. Maybe the objects can change, the materials can change, the light can be passing through different materials depending on our perspective and where we're standing can change things, the light source can be different, all of that stuff, okay? So it's really important to understand those things. Any questions on this before we move to the model? Or once or twice, sold. All right, so now on your cycle 3 model page, choose one of those scenarios to make a model on. So we have a black object and a white object under the same lamp. Okay, what would be the difference? How can you show the difference between those two materials in a model? Right, just saying black and white is not enough, you have to show it. Or option 2, a shiny object and a rough object. So this would be shiny and this is rough under the same thing. So how can you explain that in a model? What is happening? What would the arrows look like? Okay. We need to make sure that we have the light source, the objects, what's happening to light, the reflect, absorb, transmit, arrows, light into the eye, have at least one process label that explains why the object looks different. So why do the two things look different?
What is the
This would be shiny. This is shiny. So why is something shiny and why is something not? Why is it dull? Or what happens with white and black paper? So you have a few minutes to work on that. And then we'll go over what is a good one versus one is not.
I don't say. How much
Half is nice. But if you want to use more, go for it.
What happened?
You tell me.
Then I
I would say something.
that he has a problem. We change the song.
In this model, you wouldn't have to. Because you're not looking through a translucent. How can you explain with arrows what's happening between the white paper and the black paper? And what is that going to look like in your eye? So you have one eye, you have those objects going into the eye, what's different about it? Why is black different than white? Why is shiny different than dull? Why? Yeah. Yeah. And we're going to show interactions of the object. And those the interactions have to be different because you're seeing different things. So how can you show different interactions at each object? What is happening? What happens with black material as opposed to white material? What happens with shiny material as opposed to dull material? Yeah, and then again, where's the eye? And then how are you gonna show it different from the paper cut? Because it can't be the same, right? Because they look. That you're seeing. We're trying to model one of these scenarios, obviously. Either black object versus white object under the same lamp, shiny surface versus rough surface. Are we black piece of paper versus a white piece of paper? A black cup versus a white cup? How do you show that? So how do you show that in a model?
But so that doesn't reflect.
Is the black paper reflective? Can you see it?
Yeah,
So is it reflective?
but a little.
Probably less. So how do you show that in the model? How do you show that it's reflecting less than the white paper?
Like things.
Another minute or so.
Yeah.
Okay.
Should I?
These are two.
How is it
Try
that
to have
like
one
what?
eye
No,
because
that
you are the
much.
one seeing it. So everything should be trying to interact with one eye. What's up?
How is it like it reflects but not that much?
That's right. How can you show using arrows? Because that's right, that's the way we communicate. How can you show one object is reflecting more than the other? Would anybody do the first option and want to
I did.
look at their model here? Put your model under the thing. Just so we can give you some feedback.
I need to explain it.
Hopefully not. It's a good model. Right? Okay, so we have, all right, so you had two different eyes, and the way you showed that the black paper is different is that like a less of an error?
Yes.
Okay. Another thing we could add is more absorption too. If we're talking something about that, making an annotation. Okay. And the other thing is try when we're doing our models to just have one eye. Or the two eyes together, because then this is like two different people looking at it. And that could mean maybe their eyes are different or something. So try to have one eye because you're seeing both things. Okay, so thinking about how we can do that, but really good job. And some other things too is here, what is this light doing? It's transmitting, so I can have a T there or something like that.
Okay.
And then it reflects off and then absorption. So making sure we have those levels there. Thank you so much. So it's horrible to have to share things. Second option, did anybody do the second one about the shiny versus dull?
But I don't want to show.
I'll just.
No, I don't want that. No, I don't. Because it's bad.
It's not bad. Manuel?
I didn't give you enough time to like
All right, so we have the light source. Ooh, my eyes are very blurry. Let's do this. Violetta, can you turn the lights on? Not too bad. So we have the lamp, we have absorbed, the rough object is absorbing and then reflecting. Did you have the shiny object too? It's up here. You did two different things. Got it. same sort of thing. So you did kind of more arrows up here to show more energy, more light, and less arrows, and they're actually like dashed. Yeah. Cool. One thing I do want to point out, and I'm not saying this is what you're doing. When I look at some models, people use like a bunch of different arrows, which is fine. But if our expectation is like 5 arrows, that doesn't count as multiple arrows, which you're not doing. But some of us, if we do a model, we just draw 5 arrows on it. Like we think that that might be good enough, but it's not. Okay, so excellent job.
Can I put mine?
You want to show yours? Yep. Go.
Yeah.
Because I think mine is bad.
You want to put it on the camera when we look at it?
Sí.
And give you feedback.
This is like this. Is this part?
All right, so we got black paper versus white paper, both entering the eye. Again, dashed line, that's less light than over here. Okay, so that makes sense. Again, make sure we have A, we have E. Do you explain those letters somewhere? Is that up there? Okay. Make sure if we're using shorthand, which is a great strategy, that we do explain what the letters are, that we have a key on the model to help people out. Okay? Cool. Awesome.
I want to show.
Go,
And mine
please.
is like not good. Not for you.
I'll put it. When Martina gets back, if she gets back in 30 seconds. So we have the eye. Again, we have the arrows bouncing off the rough, but it's less because it looks darker here. I would say here, are these arrows getting to the eye?
No.
So that would be something that we could improve upon.
Yes, that I told you how I can.
But it's practice. This is what we're doing. You're getting feedback on. Okay, cool. We have the thing. Oh, very nice. Great key here. So this is very effective. Okay, so this saves us room when we're trying to explain things. Have a key there. Cool. Oh, awesome. Well done. And then yeah, cool. Awesome. All right. If you want to take a moment to look at your model to make sure that it kind of hits those spots to make sure that you have to be able to assess it. Or he's not back. And talk to your partner real quick. What is the difference between transmit and transmits but scatters? Check in real quick.
Bueno, transmitir solo transmit el objeto transmit sí pero si hay
Let me try to explain something. If you'd like to go ahead and turn the lights back on. So if everyone takes a look up, right, the light has covering on. That covering is translucent. It's not transparent. Okay, so it's making the light less organized. There's still the same amount of light here as would be if it was clear, but it's scattering and it's less organized, a little softer. Okay, so there's still the same amount of light. It's just less organized, so it's getting less organized. It just spreads it out more, and then it kind of dims it down a little bit. It makes it less harsh because those lights are super harsh, like they irritate eyes. No, because now we're in 9 minutes. Okay, Raphael, what's the difference between transmits and transmits with scatter?
The difference of transmit is like
Amber, Mahina.
What you say, Rafael?
Yeah, M. Because there's 2 of you. What's the transmits and transmits with scatter?
When it transmits, it's clear, but when it scatters, it's like borroso.
It gets blurry. Okay, cool. Okay, this idea of spreading is less organized. Cool. Oops. Question 1. Why is the brain important for seeing?
If you don't understand things,
The whole idea is it interprets, right? That's our organ, and that's how we
I put
understand the world.
I put
To understand the things that you're seeing
it receives the
To perceive the information.
Mr. Light. And to understand the things that you're seeing.
It uses signals to make us see. I did interpret.
And Mr. Light, it let you see the things you're seeing. It let you
Because
understand
again, even like
the things
if
you're
you think about our vision, like what you see right now is not it's not in your eyes right now; it's in your brain. It's weird. If two people look at the same setup but describe it differently, what is one scientific reason that can happen? There's many, but what would be one? Write down your thoughts.
One side is transmuted, one side is transmuted but scattered.
Doesn't feel good using words? It's nice, isn't it? Question line.
Brightness, material, position. Okay? It even could be brain, right? I had seen something, I don't know if this is true, but I thought it was fascinating. There were some historians that believe like the indigenous people of the Americas weren't able to see the Spanish boats because they had no concept of things that big. Right? So if we don't have concepts of stuff like what do babies see? Because they don't understand the world. Their vision must be different than ours because they can't interpret things. Right? And your brain doesn't have to think all the time. Chair, pen, desk. Like you just see stuff. Okay, but if you don't have access to those words, that must change how you see things.
Mr. Light, if I put like a different because one boy could see with different materials is good.
Through different materials?
Yes.
Okay. In the box scenario, what changes when a translucent material covers the window? So, what happens when I do this? Hopefully you understand we're getting scattered light, less organized, makes things dim, blurry. 4, what is the full system change for seeing? So it's 5 turns. 5 turns.
We have to put light.
Then if electricity enters your brain to see, where does it go? Any thoughts on that? It just get released out of your
I
body.
could see.
6 is better than 5. Source, interaction, light enters eye, retina signals, brain interprets. Those would be the basic 5.
Mr.
Okay,
Light.
you can add more as long as it's in the same, as long as it's in the right order. Right? If I say interaction, the lens focuses the light on the retina, and then light enters the eye, that would be wrong. Right? It's out of order. 5. What is one sign your model's hypothesis?
Arrow
label.
and sketches.
Making the most important is the arrow direction. You get arrows coming out of the eyes, is automatic one.
Yo te dije que eran arrows.
Okay, making sure those process labels are in. When chairs are pushed in, I'll start trivia.